Hey everyone, so off out to the workshop, and in this video we're going to be making a turbine for the hydroelectric install I'm doing, full installation. It's about 1 kilowatt turbine, sort of average around that mark, 1.5 peak at really high flows, but it's going to be something a bit different from mine, because I've been developing, with the help of my friend John, a 2-inch BSP spear valve nozzle, with the idea being that you can have one valve that does a really broad range of flows, and that's what this turbine is going to be getting. So here is the spear valve we've been working on, 2-inch BSP spear valve. Now it's a bit messy, we haven't focused on absolute perfection with it, it's a prototype. As you can see, it's a 2-inch BSP, so we can run really high flows through this, and in this job it's going to have about 5 litres per second going through it, with about 40 metres of head, something like that. And as you can see, we wind out this, which I'm going to make a bigger handle for this actually, and we wind this out, and as we wind it out, the orifice opens, allows water to flow out. So with this, what we can do is we can have one nozzle with one pipe, so more efficient, one nozzle doing a very big wide range of flows. So that's the idea behind that. It's a brass and stainless steel combination. Anywhere where stainless steel's touching, it touches brass, so that you don't get locking problems, because stainless steel has a tendency to bind to itself. So we've got brass rod inside there, and stainless steel spear, and brass nozzle. And yeah, we're going to put this on this turbine, and eventually it will get changed for an updated model, because we've already started work on Mark II. But for now we're going to put this one on it and see how it works out for the customer. For those of you who've been watching the Hydroelectric videos, you've probably seen that I'm working on my my own spoon design. So this is the new updated version that slants back, which I found is a bit more efficient. And this is the small version of it, just 3D printed. Obviously they're not actually going to be like this once they're made, but this is going to be scaled up, made much bigger for different situations. But it's not ready yet, I haven't got any made. So for this turbine, we're going with these type of Turgo spoons. These are rated for 34mm jet size. This has a 22mm jet, so they're about right. The other ones I use can't take the jet size that the spear valve comes out. The ones that are on my turbines, we're having to go with the next size up, which these, and these will be quite well suited to that nozzle size. So that's what we're going to do. So we're working off of a CAD model which I made yesterday and the day before, and I've got the runner disc here. It was a DXF file. I'll try and get the actual turbine itself made today. Rough cut it out on the plasma table, and then manually drill the holes very accurately, machine out the middle on the lathe. So that's the first job. We're going to make the turbine itself. So let's get to work. Right, stainless steel is very expensive these days, so we're doing a trial run, running through the program, just making sure it's doing the right thing without the plasma cutter on. I'm just doing a bit of steel. Seems to be doing the right job at the minute. So I'm drilling the holes rather than plasma cutting them out. I'm just boring a singular hole down. Does seem to be working. So here is our rough cut out disc. Needs the holes machining out accurately, and as you can see, for some reason it skipped 2 holes. It's because of my power system. I have to pause it to let the air compressor start up again. Then when I start it, I haven't figured out how to get it to start the torch and then bore. It goes to start it and misses a hole. It's my fault. But there's no point wasting the piece of stainless, so I'll just manually figure out where they need to go and drill them out. So now it's just tidying this up and machining it out. there we go. That is our plate, runner mounting disc for the Turgo spoons. The backs of them sit against here. This allows it to take more power. It doesn't actually need it for this job, but why not? You know, make a quality job of it. So that's our turbine, Turgo Turbine. Mounts this way up. Jet will be coming in from here and getting split between two spoons. Yeah, we've gone quite big with it. It's quite a lot bigger than mine. One, because of the jet size, and also because of the head elevation and the type of alternator I'm using. I wanted to slow it down a bit so we don't get too much voltage to cook the charge controller. By coming a bit bigger, we lower the RPM a little bit. Hey everyone, so I've just got my turbine parts laid out, so just need to assign them a cutting command, and then we shall cut them out with this piece of stainless steel. But it's very expensive stuff, so we don't want to make any mistakes. Right, we are ready to mount the alternator. Right, so that stage is done, the housing. So the next job is to make the boss, which connects the turbine to the shaft of the alternator. Yeah, very pleased with it. Very, very pleased. Today's job is to make the boss for the turbine, to mount the turbine to the output shaft of the alternator. We've got this 2-inch piece of stainless steel, 304 stainless steel, and we're going to make quite a complicated part with no mistakes. So let's get that mounted, faced off. And the first job is to drill a 12mm hole all the way through it. Let's get a bit further in, about there. Right, because I don't have a rotary table, I have a digital readout on my milling machine, but I'm not that familiar with it. But what I've done is I've put this temporary locator ring on here, which fits this very, very nicely and tightly. So I'm going to locate that on there, and then I'm going to mark the holes of this, because then I can't get them wrong. And if I was slightly out when doing these, they're still going to line up. So it means it'll only line up in one spot most likely, but that's how we're going to have to do it with the tools and machines I've got. So that's located, so we'll make a tool now to mark these very accurately, and then I'll drill these out. The holes drilled out, so now I'm going to cut a piece off of here to be that clamping plate, and all these holes will line up obviously because they're already drilled all the way through. So we're going to cut a slither off this now. I've just machined that location I had on there off, cut a slice off, then we'll machine that locator back on. Right, so I've chopped that piece off of there. Now we'll machine those faces off on the lathe. Square everything off again. Our plate that clamps everything down from the top. Those holes just need drilling out to 6s because currently they're tap-in size. Right, the next job is to bore out this hole to the correct size for the output shaft of the alternator. So I've got a drill bit here which gets us within 0.5 of a millimetre, and then we'll ream out the rest to get an accurate fit. It's very important to have an accurate fit here. All right, something like that. So I bored it out with a internal boring bar, and it's a really nice fit, really nice. Not too tight, so it'll be easy enough to come off, it won't bind up, but it's touching, you can feel that it's touching, there's no play, and you can hear it all the way up. Perfect fit that is, I'm really pleased with that, because it's quite difficult to do that. So yeah, excellent. And it bottoms out there, and there'll be a 12mm bolt holds that in. That goes on there like that, and then this goes on here, and then that on there. Looking good. Looking very good, although that's upside down. Right, I need to tap these holes now. I've just cut these 3 holes. These are going to act as a key because I don't have the ability to cut an internal keyway, unfortunately. If I could, then I'd cut an internal keyway, but I can't. So with these 3 6mm bolts, we'll go through and lock into the key. And yeah, I'm really pleased with how this is lining up nice and tight at the moment. It's excellent. I haven't tapped the holes. I've got them started on the mill, but my tap's feeling a bit blunt and I don't want to risk breaking one. So get a new tap and finish them, and then the boss will be done. Just lining up my jets and everything. So I haven't quite finished the boss yet because I need to get a new tap because I'm going to risk breaking a tap if I carry on. They're all started, but I need new taps. So I'm going to start fitting the nozzle. Now, I've drilled a hole where my model, from the CAD model, where it says my jet should be. And then I'm just poking this poker through just to check for my jet alignment. I hope you can see that. No, you can't, hang on. So you probably see a little bit better now. But yeah, that shows me the jet alignment, shows me where we're facing. And that's pretty good. It needs to move over a tiny bit, slightly further into the cup. I went out this morning, got a new tap, and yeah, they're all tapped to the right depth now. It's all sitting nice and it screws down lovely. It's exactly as I wanted it, so I'm pleased with that. So the next job is to assemble, but I have a little problem. So I haven't got long enough bolts to assemble this properly. And I've got the wrong size washers. They're on order, but stuff takes a long time these days to get, and I ordered them a few days ago and they haven't come in yet, so I'm going to put it together with these, but there's not enough stick out and I don't have enough bolt to get a washer on the back, so I'm going to have to take it apart. But we'll get it in a position where we have it all together, get it on site and fitted, and all I have to do is lift it up, flip it over and just change these. Won't take long. Yeah, so let's have a clean up of this and then we'll start assembling. So for those that don't know, this is a spear valve. This is an adjustable flow nozzle and also can turn the water off, i.e. the name valve. So it uses this spear shape. Water comes from the outside of here. It runs around this spear and tends to cling to it. And then in the nozzle, there's a corresponding taper, which is the same as the spear, Sorry, I haven't got great focus, I don't think, but yeah, in there you can see that's the same shape as the spear. The spear can then push against that and seal it, or be moved in and out to create variable flow rates. They're very good. A little bit less efficient than a fixed nozzle, because you've got all this space taken up in here by, you know, all this stuff that needs to be there. But you can have such a wide range of flows with them, you can have less nozzles, and there's an efficiency saving there. The reason I haven't used them in the past is because we haven't had a 2-inch one that's big enough for most of my needs. But me and my friend John have been working on this now for a while, and this now can do 4 litres per second at 20 metres of head. So it's sufficient for this job to be just a singular nozzle, which works out very efficiently. And that spear gets adjusted in and out on here. A lot of work goes into making one of these turbines. You know, there's you can buy stuff mass produced, and nothing wrong with them to get started. You know, the Chinese ones or plastic ones by a certain company. They say they serve a purpose, and I'm not having a go at them at all. But to get really good efficiencies, you've got to be custom made to the site's conditions. And that's what this is. This is a custom made turbine, exactly made to the site conditions. Right. Yeah, that one's going to. Next is the turbine, which will have to come back off yet. Normally I'd probably put a little bit of Loctite on these bolts, but like I say, we're going to take it off again yet, so we won't do that. Jet hits in the spoon there, water blasts out this way out the bottom. Yeah, very pleased with that, looking excellent. Right, let's flip this back over, it's getting heavy. How about that for a bit of rain then? It is chucking it down. Oh, thunder and lightning. Just finished this 3D print. It's a handle I had designed. So that basically slides over there. This is made by my friend John. He's done the machining for this. He's done the support rod, the spear, and the mechanism here. And he uses these because it's, you know, what he knows how to do and what he's been doing for the smaller spears. And it's fine. When we tested this, it's fine for the smaller ones he does, but on this, because it's quite a big flow, he said it can get a bit hard to turn that small diameter when, you know, there's high pressure in there. So I've 3D printed a nice big hand wheel that will slide over there, much easier to turn. I might have gone a little bit over the top with it, but it is nice and easy to turn. So let's get that slid on. It does look kind of out of place, that. I might make that a bit smaller if I do it again. It's the first time I printed this prototype. But I have to say, it does look out of place, but it feels really nice. Got a lot of purchase on it. It does feel very nice, so I don't know. And the idea of it's not for looks, it is for function, so we might leave that like that. Let's just get that down a little bit further so it butts up to the end. That's it, like that. That close all the way. Yes, it does. That's it. Should look a bit better in silver, shouldn't it? So we'll give that a try once that dries. Blend it in a bit. Right, hey everyone, I'm on site, and as you can see by how wet and muddy and hot and sweaty I am, it's chucking it down with rain, which is a good thing, because we're actually at flow rates now that this could be on. It should be around there somewhere. There we go. Just like that. We'll go up and have a look at the intake in a bit. I'm not here all day, I haven't got that much to do. Just come to fit this and work out the manifold. Oh yeah, the other thing from last time is I got a new gauge, and we're at 50 psi. I've actually got it turned off, so it's reading 30 at the minute, but we're at 50 psi. I'll show you that in a bit. These are getting chemical anchor fixings, because you know, I don't want to put expander bolts so close to the edge. Right, the anchors are set. We've got washer, then a nut, and then washer again, and the turbine sits on there bolted down to that, and then that gives a little space underneath for any water in here to drain out into the drainage hole. So a way of not needing another drain. So let's get this turbine on again. So we've got a new gauge. Just turn the valve on because the valve's off at the minute. There we go. Bouncing around a bit. Can you see that? I'll move you in. Trying to get it to focus, but yeah. You can see, there we go, 50 psi. So 50 psi will get a kilowatt at about 5 litres per second. Might even be 51. So I've been having trouble a bit with the focus in here, so hopefully it's okay. But I'm gonna run a bit of water through all this and just check that it's draining out under the turbine as we planned. Just take this off of here. Let a bit of water run through. I'll take that home with me. Right, let's open up the flood gate a little bit. Not too much, just as a test, make sure we're draining. There we go. Hey. Too much, a bit of sediment in there, you see. There we go, that's more like it. Don't want to get everything soaked. Yeah, it's working. Yeah, the drain is working excellent. It's flowing out underneath the turbine, I'll show you. There it is coming out the building. There's going to be some EPDM liner for the first couple of meters so we don't erode under the foundation. It's just another job on the list. Right, so I'm up at the intake, and as you can see, I haven't cleaned it, and it's working really well. Actually, it's really clean considering the amount of water we got flowing. So as you can see, there is a bit of an issue with it hitting that fitting, so I might have to make a little something to stop that, because that's not quite ideal, that. But look how good that's working. That is really good. What a difference a few weeks makes, eh? So that now is well sufficient flow for us to have a kilowatt off the system. That's a lot more than 3 litres per second, 5 litres per second. As you can see, we've got a little bit of air getting trapped here, so I haven't got around to trimming this yet and shaping it, and we need to come to this edge a little bit, but it's working very well. Very well indeed. It's hardly got blocked up at all. That's 3 weeks that's been going like that. Anyway, happy with that. I just need to have a little strip of metal or something to stop that blending in. I've just put a rock there for now. So I'm back home, and the installation of the turbine on site went really well, and I'm really pleased with how it turned out, and I'm really sure it's going to do a really good job. I had a really hard time filming it though. Had camera focus issues, and then inside the small building my sound went all way too loud. It's very difficult making these videos on my own when I'm trying to focus on what I'm doing as well. So yeah, sorry for that. I tried to edit the audio as best I could, but I've got these new microphones and they're very sensitive. You've got to get everything just right. But yeah, other than that, all good. So the next job is going to be to make the manifold to connect it up to the pipe, and then it's just wiring it up, and then it's going to be turning it on and hoping we get what we said it was going to get. Quite nerve-wracking, but I'm sure it will. Anyway, that's going to be the end of this video. Hope you enjoyed it, and thanks for watching.